Hi everybody. We are going to meet today for a live lesson where we will be going over this practice test together. But I did want to also make sure I had a video for you in case you need to miss the live lesson or you need a little bit more than just the recorded lesson. So anyway, for the first section, what I want you guys to make sure you know is the keywords for each of these transformations. So as far as translation goes, remember you can look for the SL here and the FL in reflection and the T's in rotation. And that helps you to remember translation is slide, reflection is flip, and rotation is turn. Those are the key words you want to try to remember. Number 2, dilations always result in images that are blank to the pre-image. So when you have a dilation, it's either making your image smaller or larger than the original, so it's not congruent. However, we learned that the proportions of the sides stay the same and the angles stay the same, and that means that we get images that are similar. So dilations result in images that are similar to the pre-image. On the other hand, translations, reflections, and rotations always result in images that are completely congruent. Even when they're facing in a different direction, they're still congruent. Okay? So there's going to be a little section at the beginning of your test with some vocab and some fill in the blanks, okay? Number 4, you're going to use this triangle to answer these two questions. So for the first one, if triangle ABC is translated 2 units right and 1 unit down, what are the new coordinates of point C? So all you have to do is take a look and see what the coordinates are of point C. So this is 2, -5. And we're going to be imagining we're translating it 2 to the right. So that would be 4, sorry. Or in other words, we're adding 2. And then if we're going down, we're going to subtract 1 from the 5. So that would be from -5 going down to -6. So the new coordinates would be 4, -6. Will the triangle have the same orientation? So remember, the orientation is talking about the direction that it's facing. Okay, so yeah, when you translate, the orientation stays exactly the same. Remember we did it at our opening tasks. We took the pen or whatever it was, phone, and we just slid it down the way that it was facing and all of that fun stuff. That all stayed the same. So when you do a translation, it stays the same. So the orientation will stay the same. So that is yes. Number 5, showing you the translation rules written out algebraically. If we're looking at this rule, what's going to happen to the figure? So first look at the x. If you're subtracting 2 from your x, that means you're going to the left, right? So you're moving left 2 units. And if you're adding 1 to your y, you're going to go up 1 unit. So for the x's, remember this is just off to the side to help you. For x, if you're subtracting, it's left, and if you're adding, it's right. But for y, if you're subtracting, you're going down, and if you're adding, you're going up. Okay? For number 6, a figure gets larger when we dilate with a scale factor that is greater than 1, right? So any scale factor that's larger than 1 is going to make our figure larger. If we dilate with a scale factor that is less than 1, it's going to get smaller. So, right, we're talking about like fractions like 1/2, 1/3, etc. It's usually written as a fraction. Number 7 says use the triangles below, but of course that's on the other page. So we're going to turn our page. And we're going to translate triangle DEF 5 units to the right and write the new coordinates. We're also going to do this on the page as well. Okay, So actually, you don't have to do it if you don't want to. I'm going to do it. Let me just get my pencil. Here it is. Okay, I thought I had it right there. So we're going to translate it 5 units to the right. So 1, 2, 3, 4, 5 is D prime, E prime. 1, 2, 3, 4, 5. And then F prime. 1, 2, 3, 4, 5. Okay, and connect. And my new coordinates are going to be D prime is 2, 0. E prime is 3, -4. And F prime is 1, -4. Okay, those are my new coordinates. Now I'm going to take DEF and I'm going to reflect it across the x-axis and write the new coordinates. Now, if you're not told to draw the image, you can just write the new coordinates easily. Remember, I'm going to write down the rules for you real quick. When you reflect, if it's the x-axis, you keep x and change y. If it's the y-axis, you keep y and change x. Okay, and when I say change, I mean the sign, right? So let's just write reflections. Okay, so if I'm doing the x-axis, my D is going to keep the x, which is -3, and it's going to change the y, which is 0, but it's not going to change because it's 0, right? Do you think you could stop that for a second over there, my little darling? Thank you. And now E prime, we're going to keep the x, which is -2, and change the y. It was -4, now it's going to be +4. And F prime, same thing. The x is -4, so it stays, and the y changes from -4 to +4. Okay, so now I'm just going to show you how you could have done this by drawing it. If we're reflecting to the x-axis, remember, over the x-axis, we count to the x-axis. So D is 0 away, it stays there. So D prime is still there. E, we count how many away we are, and then we go that many in the opposite direction. So 1, 2, 3, 4. 1, 2, 3, 4 is E prime. And F prime, 1, 2, 3, 4. 1, 2, 3, 4, F prime, connect, and we're done. Okay? There you go. Now, if you were plotting all of these on the same thing, you would need to show that this is a different transformation by putting 2 dashes. But since we're not doing them one right after the other, we don't have to here. Okay? And then, of course, you can check that you wrote the same coordinates, -2 and 4, and -4 and 4. Finally, we're going to rotate it 180 degrees around the origin, And remember, 180 degrees is the same either way. So if I turn it to the right or the left, it doesn't matter. 180 degrees is 2 turns. So it's going to be in the second quadrant. So I'm going to write my new coordinates. D is, I'm just going to write it here. D is going to be 3, 0. E would be 2, 4. And F is going to be 4, 4. Okay, so now I go back and I'm going to try to, I really can't really graph it here, but you're not asked to. If you were, you could just do it over this triangle. 3 and 0, 2 and 4, and 4 and 4. Oh my goodness, Drew. Okay, and that's what it would look like, okay? But the new coordinates, again, I will just rewrite them. We had 3, 0, 2, 4, and 4, 4. Those are your new coordinates. I will tell you on the test, you are going to have to write new coordinates, but you'll also have to graph them as well. Okay, Finally, to finish up, number 8, we're going to write the new coordinates of an image after the following. For part A, we're doing a dilation of a half for a figure who has these original coordinates. So if you're doing a dilation of a half, you're multiplying by half, which is the same as just dividing by 2. So you're just going to take each coordinate and divide both x and y by 2. So 4 divided by 2 is 2. 2 divided by 2 is 1. That's your first new coordinate. Now we're going to change this one. 2 divided by 2 is 1. And 0 divided by 2 is 0. And then finally, 8 divided by 2 is 4. And 6 divided by 2 is 3. And those are your new coordinates. Okay, and to finish up, we're going to now write the new coordinates after a dilation of 3 for the same figure. So we're starting off with these and applying a dilation of 3. So now we're going to multiply by 3. So 4 times 3 is 12, and 2 times 3 is 6. Then 2 times 3 is 6, and 0 times 3 is 0. And our last coordinate point will be 8 times 3, which is 24, and 6 times 3, which is 18. And that's the answer. So that's all you need to know for the test, guys. I tried to make it simpler than I normally would have, being that we are away from each other. Okay, so I hope this is all right. Make sure you come to the live lesson where we go over all of this together. All right, have fun reviewing.